Okay, let's take a look at this problem. A rental car agency charges $15 per day plus 27 cents per mile to rent a car. And we want to determine a linear function that can be used to calculate the cost of daily car rentals. And we are told that we let x be the number of miles. So in this problem, there are two terms. One is the number of miles, and the second term is the cost. The cost of renting a car. So, because the cost of renting a car is depends on the number of miles. Number of miles driven, right? Because the more miles you drive, the more you have to pay. So in this problem, the number of miles is independent variable, and the cost is dependent variable. And because we are told we can use a linear function to model this problem, so the function we're looking for is something like this: fx equals mx plus b. So once we can determine the m, the slope, and the y-intercept of b, then we can find this function. Okay? So let's go back to this problem. Because it says it charges you $15 once you rent the car. So this means even though you don't drive the car, but once you rent the car, you have to pay for $15. And it charges you 27 cents per mile. So if you drive 170 miles, then you're gonna pay for this is $15 and plus the cost of this 175 miles. So this will be 15 plus 0.27 times 175. So you are going to pay $62.25. And if you drive 230 miles, you will pay 15 plus 0.27 times 230. So you will pay $77.1. And if you drive 300 miles, you will pay 15 plus so you pay $96. And if you drive 480 miles, you pay 15 plus 0.27 times 15 plus 0.27 times 480. Okay, so once we found this once we found these numbers, So each two number is corresponding to an ordered pair. So 175 is corresponding to 62.25. Now we put 175 as x because we have said, so here the number of miles is our independent variable. So the independent variable is x and the dependent variable is y. So that's why we put 175 as the first component and the 62.25 as the second component. And similarly, we can write another ordered pair, 230 and 77.1. Okay. Now, next, to determine this linear function, we have to determine the slope and to determine the y-intercept of b. Now, the slope, we can find it using the slope using this formula. So here, if we let 175 be x1 and 62.25 be y1, so 230 will be x2 and 77.1 will be y2. So we can compute the slope. So it is 77.1 minus 62.25 and over 230 minus 175. So this is the numerator is 14.85 and the denominator is 55. So the slope is 0.27. Now, after we found the slope, next, if we use this formula, the point-slope form, if we use the point-slope form, we can find the equation. So far we have these 2 points. So we use one of these 2 points, and then use the slope. 0.27 we just find. So let's say I use this point. So the equation will be y minus 62.25 equals 0.27. 0.27 times x minus 175. So if we simplify this equation, we will have y equals 0.27 times x minus 170 plus 62.25. So we have 0.27 times x minus 0.27 times 175. So it's a 47.25 and plus 62.25. We'll have the answer. So this is our linear function. Okay, this is our linear function. So y equals 0.27 x plus 15. So here the slope is 0.27. So the slope here is equal to this price. So the slope is the unit price. So here it means how much it charges you for every mile. And the $15 is our y-intercept of B. Here it means this fixed charge, the $15. Now use the same way, use the same method, we can do the second problem. So in this problem, we're given that you pay $77 for driving 210 miles and pay $101 for driving 330 miles. So in this problem, we are given these two ordered pairs. Now, also keep in mind the number of miles is the x. So 210, 77, and they are given 330 and 101. So then, first you use the formula to find the slope, and then use one of the points and plug into the point slope form. Then you will be able to find this linear function.